We're asked to obtain this equation for dy by dx. This is implicit differentiation. So first up, I'm actually just going to expand that bracket. Right, now it's ready to differentiate. So we can differentiate each side. The left-hand side, we're going to need to use the product rule. Differentiate 4x to give 4 and times by y. And then it's 4x times by the derivative of y, which is dy by dx. And then on the right-hand side, we've got 4x plus, now when we differentiate 8y squared, basically just differentiate it like we would x, but stick a dy by dx on the end. So it's going to become 16y dy by dx. What's actually happening here is we're using the chain rule, and we're differentiating the outside, which is essentially our function, something squared. So it's 2 times f of x, but then we have to times by the derivative, f dash x, or in this case, dy by dx. And then for the other one, it's just going to be minus 9. Right, now to rearrange. I can see in my final answer it's 4x minus 16y, so I'm gonna minus the 16y dy by dx from both sides. So 4x dy by dx minus 16y dy by dx is going to equal 4x minus 4y minus 9. I can factorize out dy by dx here, so just get rid of that and make a bracket. And therefore dy by dx is 4x minus 4y minus 9 all over 4x minus 16y. Now, we're told at the point P on the curve, the tangent to the curve is parallel to the y-axis. So if we drew the tangent, it would be this vertical line. And at Q, it's parallel to the x-axis, so it would be horizontal. Now that means, well, for Q, it means that at this point, dy by dx must equal 0. And then for P, it means that dy by dx, well, it's infinite or not defined. Another way of saying that, by the way, is to say that dx by dy is equal to 0. Sometimes people like to flip it around and then make it 0. But I'm going to focus on it not being defined. So I think I'll first of all look at Q. Dy by dx is equal to 0. Now the only way dy by dx can equal 0 is if the numerator is equal to 0. There's nothing that the denominator can equal to cause dy by dx to equal 0. So it must be that 4x minus 4y minus 9 is equal to 0. And that means I can rearrange to get, because like that's going to give me a condition for y in terms of x, but we also know on the curve that this is true. Well, actually, let me stick with the not the expanded one, that is true. So I'm going to need to solve simultaneous equations essentially. I'm going to make y the subject, so 4y is going to equal 4x minus 9, and therefore y is going to equal x minus 9 over 4. I'm ready to substitute it in. So I substitute this into here, that's what I'm saying. Therefore 4x times x minus 9 over 4 is going to equal 2x squared. I didn't really think about whether to substitute x or y in. It's actually going to be a little bit simpler to substitute y in because there's only 2 terms containing y, whereas there's 3 terms containing x. So 2x squared plus 8 times y squared, that's going to be 8 minus 9 over 4 squared minus 9x. Okay, just need to carefully deal with this now. So that's nice, the fractions cancel. Okay, I'm gonna Yeah, I'm going to expand the bracket and then I'll times by 8. I might straight away just cancel this out to make it a 2. So 2x squared minus 9x equals 8x squared minus 36x plus, it's going to become 81 over 2. Of course, use your calculator as you need to. These are going to cancel. It's quite good. It's going to be, I can cancel that out with that to leave me 6. I'm going to get 0 there. I'm going to need to times through by 2. So 12x squared minus 72x plus 81 is going to equal 0, but there's a common factor of 3 here. So divide through by 3. We could just, to be fair, oh no, we have to show detailed reasoning, so don't just stick it in your calculator. 3 is into 72, I'm going to go 24. Okay, let's give it a go at factorizing. So I'll try 2x and 2x, and then 9 and 3, and that actually checks out really quickly. They have to both be negative. One little trick you can do, you may or may not be aware of this, is you could sneakily put it in your calculator. And then we get answers of 9 over 2 and 3 over 2, and you can work back to get this as the factorization if you struggle with factorizing. So x is going to be 3 over 2 or 9 over 2. There's 2 points where we're going to get this 0 gradient. The other one's going to be up here. It's going to be a larger value of x. So q is the smaller value of x, therefore I'm going to reject the 9 over 2. And then I can find the corresponding y value. It's going to be y is 3 over 2 minus 9 over 4, which is going to be minus 3 over 4. So we've got q sorted. 3 over 2 minus 3 over 4. I'm just going to put a box around it, not because it's my final answer, but just to highlight it. All right, now on to finding p. So this is where dy by dx is not defined. Okay, so it's going to be when the denominator is equal to 0, when 4x is equal to 16y. My other way of thinking about it was to find dx by dy, in which case you just flip it around, set equal to 0, and then you get exactly the same thing. And that's going to mean that x is 4y. It makes a bit more sense this time to substitute into our original equation for x, I think, to avoid any fractions. So I'm going to give that a go. So 4 times 4y times y 16y squared times 2, 32y squared. I can cancel this with this partially. So I'm going to get 24 y squared minus 36y is 0. Divide through by 4. Actually, what else? 12. 2 and 3. So y equals 0 or 3 over 2 for p. Now there's two places again where it's not defined. One of them is the origin. That's the point I've just found with 0. So p is going to be the 3 over 2. And therefore x is going to be 4 times that, which is going to give 6. And therefore we've got p 6, 3 over 2. So we're nearly there. 6, 3 over 2, and 3 over 2 minus 3 over 4. We're asked to show the distance PQ is k root 5. So questions don't normally require you to do both of the calculations we had to do. It is here. And in addition, we've been asked to work out this distance. But it's not too bad because, I mean, you could draw a triangle, but we can just use y2 minus y1 over x2. So not over, but y2 minus y1. That's going to be our change in y. So 3 over 2 minus 3 over 4, so plus 3 over 4, which is going to give 9 over 4. X2 minus x1 similarly is going to be 6 minus 3 over 2. It's going to be 9 over 2. And then finally, I can just square and add them. So I'm trying to find a bit of space. Here we'll do. So PQ is going to be the square root. Okay, I think at this point I'll use my calculator. You should get 9 root 5 over 4. So I'm going to write it as 9 over 4 root 5 because then it's in the form that was asked for, k root 5. Yeah, we could put it over a common denominator without a calculator and everything, but I think I've shown enough detailed reasoning and that is okay. So yeah, really nice question. Well done.